Hi guys, this is Kesha Shah and I am a Google Summer of Code 2014 student with organization OpenMRS. I am a pre-final year BTech student at GSoC from India. My project is blocking algorithm for patient registration. My mentor is Judy and my weekly updates are found at keshasha.blogspot.com. Okay, now let's look at the objective of this project. OpenMRS is increasingly used for multiple data collection points across several systems. There are different models of using OpenMRS in healthcare. For example, when a user registers a patient at the point of encounter and subsequently enters all the details into the system, and in other case a clinician writes patient details on a paper chart that is later transferred to OpenMRS system by data clerks. Moreover, a program may involve a mobile tool that registers patient while out in the field and sends the data into the mainstream to create new patients. This data are combined into one record, and depending on the available data, elements are appended to an existing patient or used to create new patients. Unfortunately, most of the registration work for patients in OpenMRS remains a data collection exercise. We wish to transform this by developing and implementing a blocking algorithm that quickly uses the data elements entered during this registration to determine if the patient is existing or new to the system, or it's in the gray zone that requires processing by patient matching module implemented in OpenMRS. We aim to improve patient identification and matching and build a framework to allow for incorporation of additional data elements like biometric data, latitude, longitude to improve patient registration. We have divided the entire project plan into 7 phases. Phase 1. This includes studying string matching techniques and understanding attributes of patient registration module. This phase includes setting up the development environment for OpenMRS on my laptop and understanding patient registration modules, attributes of patients captured, and various string matching techniques. This phase has been completed. The next phase is write a program to randomly generate 0.1 million, that is 1 lakh patient data containing a few duplicate data and fuzzily matching data, that is dirty data. The Python program generates various patient attributes like patient UUID, gender, age, date of birth, if the patient is dead or not, if his death date, cause of death, given name, middle name, family name, address 1, address 2 and country. This program takes as input the number of records we want to generate as well as the number of dead patients we want to generate and the number of data. This phase has also been completed. The next phase is pre-processing the data, cleaning it and formatting it. This includes reading the data in R and generate a summary as well as write a script to load the instances into the database. This phase has also been completed. The next phase, which is in progress, is develop a blocking algorithm and techniques. This phase includes evaluating the pros and cons of multiple blocking schemes, develop a blocking scheme and implement in Python and R. In order to test it, we need to run it against the dummy data that we have generated in phase 2 and phase 3 and validate the results. Phase 5. The next phase after this is we would be integrating the blocking algorithm with patient registration module, which would include porting the blocking algorithm to the programming environment of OpenMRS platform by either creating an interface or rewriting the logic or the algorithm. Phase 6. This is the testing and bug fixing phase of new modified patient registration and resolve bugs if any. Phase 7. This is the final phase, and in this phase I would commit and publish the code to OpenMRS repository as well as provide a talk or demo at OpenMRS developer forum regarding the new feature. The link to GitHub code is this. This repository contains the code written during Google Summer of Code. Okay, let's go to OpenMRS, source, root. These are the 4 main folders. Models. This contains the logic for creating attributes of patient like address, which includes address 1, address 2, city, country, PIN, zip code, the name, The prefix first name, given name and family name, and patients like UID, gender, date of birth, age, death, if that death then it's death date, cause of death, latitude, longitude. This is the utility function. This is the helper function which is used to generate random patient data. This takes as input the number of patients with death and the dirty patients that we want to generate. This is the generated patients data, dirty patients data, and it contains the logic for dirtying the data, each attribute like name, address, age, latitude, longitude, etc. And then finally we are writing that to a file. The data loader. This includes the script for inserting values records into the tables. We have written script for 4 tables inserting values into it, namely person name, person address, and patient identifier. This is the format and we are inserting it according to this, writing a string and inserting it. And the main contains the code for generating 1 million tuples out of the using this function, generating number of patients is 1 lakh, number of patients with death is 25,000, and number of dirty patients is 10,000. And the output which I got after running this program is in the generated data. This contains, I'm sure this file would be very big as it contains 3 million lines, 0.3 million lines, which you can see its size is around 72 MB, 73 MB. This is a screenshot when the script had completed its execution. As you see, there were about 4 lakh queries which were generated and executed. It took about 9 hours to complete its execution. I would like you to provide me with your valuable feedback and suggestions as it would help me to improve my project. Thank you for watching this video.